Hello everyone, hope you're doing well. Welcome back to my channel. Today we are at day 17 of the December daily LeetCode challenge, and we again have a medium question in front of us. And this is very interesting question because here there is a lot of ways to do the stuff, and you will learn a lot basically. So if this kind of question comes in the interview, you are basically, I will say, lucky because there are so much to show the interviewer. At the same time, the question is simple, but again, you can show multiple approaches to the interviewer so that you can show all the quality that you have in terms of programming. You can display that. Okay, so this is the best question for that. This is easy. At the same time, it is good enough for you to show your skills, okay, so that you can stand out among the crowd. So coming to this question, here I will be showing two solutions, two approaches basically, and I will also prove and show you why my solution is better than the most optimal solution given by LeetCode. So the second approach that I will be showing you, that is even better than the most optimal solution given by LeetCode. Okay, remember that part. So let us begin this question. Here, let us just quickly see what I'll given to us. Here you're given a string called s, and here you're given an integer called repeat limit. Okay, so let's see the string question now. It's question 2182. Construct string with repeat limit. Okay, so you are given a string s and integer repeat limit. Construct a new string repeat limited string using the characters of s such that no letter appears more than repeat limit times in a row. Okay, so what it means, we'll see that is for example, let us say you have 5 a's, but let us say you cannot have more than 3 a's together. That is what they're trying to say. We'll see the example, that time it will be more clear. I will also write and show you the dry run of a few of the examples so that the point will be very clear to you. Okay, you do not have to use all the characters from s. Okay, remember this point. I will come and tell you like why this is not a good thing to do. I will tell you that why this will not be used in every case, because if we are not required to use all the characters, we can simply return an empty string, right? But we will not do that. I will tell you why. Now comes the most important part. Return the lexicographically largest, okay, repeated limited string possible. Okay, that means you have written the lexicographically largest answer. Okay, similar that. A string A is called lexicographically larger than string B if the first position where A and B differ, string A has a letter that appears later in the alphabet. So yeah, you can go through this part. I will just see this here. There are two things to learn. Okay, first of all, I will teach you that. Then we'll go to the question. Okay, for example, see here, let's say the two things that I have that I want to compare is AB versus and AC. Okay, so first of all, where is the first point? Okay, let me zoom in so that you can see clearly. Just remember, I'm currently explaining this particular part. Okay, I have not started the question till now. I'm just explaining this part so that you are very clear what is lexicographical, this particular sort. Okay, this is basically called the lexicographical sort. Here also the same comparison happens. Here we are not doing the sort basically, but yeah, you are using the comparisons lexicographically. Okay, that means you are comparing two strings lexicographically. So let's understand what is happening. See here, both of them are of same length. Okay, first of all, fine. Now, see the where is the first point of difference coming? If you see the first character, that is the zeroth index, is matching in both of them. Okay, fine. Now, where is the first point of difference coming? First point of difference is coming in this particular letter. Okay, that is the index number one is different in both the strings. Now, which among these is lexicographically greater than the other? Okay, so lexicographically larger than the other. So in this case, if you see, so this is the first point of difference, and in the first point of difference, the second string, okay, that is this particular string has a C present here, and the other string has a B present here at the point of difference. Okay, but since C is greater than B, okay, that is in the alphabetical order, C comes after B, that is C is greater than B in terms of the alphabetical order. For that reason, AC will be lexicographically larger than AB. Okay, AC is lexicographically larger than AB. Okay, that is point number one. Now see the other point. Again you have AB, and let us say now you have same thing AB, but again a C. So can you quickly tell me what is the answer going to be? The answer is between this. Okay, if you read this topic, you will get to know that. Okay, so they are trying to tell you is that the character do not differ. That is, see, they are clearly saying this. Then the longest string is the largest. That is idea here is, let us say AB here is exactly matching the AB here, but the second string has extra character. In that case, the one with the extra character is going to be lexicographically larger compared to the other one. So here in this case, ABC is going to be lexicography larger than A and B. Okay, so I hope these 2 points are clear to you. This is the definition of lexicographical sorting, basically lexicographical comparisons, and I've explained to you this particular paragraph. Okay, I don't want to read the text here because that doesn't make sense. If I show you the example, that will make more sense according to me. Okay, that's what I did here. Now coming to the question, they are saying the return the lexicographically largest answer. Okay, and if you now see this part, okay, do not use all characters of this. Now you will understand why it doesn't make much sense, because see here, if everything is same, then the one which has a large more characters is going to be lexicographically larger. Okay, so that is the reason why we will use this part only and only when there is no other option available. Okay, only then we will use this, otherwise we will not omit any character. Okay, that is going to be our approach. Now coming to example number two. Okay, example number one, you can, yeah, it's very simple. The reason why I'm not going to trace the example number one is that here one edge case is not coming. Okay, so if you see the example, what is happening, see here, The repeat limit is 3. That means more than 3 characters cannot be there. Let us see, the same character cannot be present together more than 3 times. Okay. Now here Z is present only 2 times. So I will write both the Z's here. As you can see, both the Z's are coming. Then if you see C, the number C is present, 4 times. But how many times we can take? We can take only 3 times. So we will take the 3 C's. Then, since the 4 C cannot be with them, so the only character that is remaining here is A. So we will insert the A here, then come to C. Okay. So this was the example number 1. You can go through it in detail, but I'll do the detail tracing for example number 2 because I've prepared that for that. Okay, prepared the stuff for that. So see, if you see the example number 2, this is the string given to you, and this is the repeat limit. So if you compare the frequencies, A is present 3 times and B is present 2 times, 3 times. Okay, both of them are present 3 times, and the repeat limit is 2. Now let us see what happens. So I'm showing the exact solution that I will be implementing. Okay, see here. First of all, we will start from Z and we'll go towards A. Okay, so if you see among these frequencies, which is the character coming first when we start from Z towards A, so B will come first. Okay, in this case, none of the characters are present, only A and B are present. So among them, B will come first. Okay, so I will write the B here first. I am writing the B here. Then, since the repeat limit is 2, I can add one more B here. So I will just write the second B also. And then I cannot have more than 2 B's together. Okay, for that reason, now I will have to put one character here. Okay, which is not a B. Now, since we are talking about a lexicographically, largest string, lexicography largest frequency here, so we will try to put the character. Okay, which is just after B. That is, then in the same order from Z towards A, the character which is after B is A. Okay, so we'll just take one value of it and we'll put it here. Okay, I'm just going to put one value here. So the frequency here will become 2, and the frequency here is currently going to be 1. Okay, fine. Now I will again come back to B. Okay. Now if you just compare, we are left with only one B. Okay. So since this is within the repeat limit, this is going to the first number in the repeat limit. So we will insert this B here. Now this will be 0. Now we will again come to A. So here again it is within the repeat limit. So all the A's can be put here. Okay. So this is going to be our answer. So as you can see, what is happening here is there will be a point where we will have to see. For example, there were 3 B's, but I put only 2. After that, I will have to search after V, which is the largest character alphabetical order in terms of alphabetical order, after V, which is the largest character present in the particular string. In this case, it was A. So I just put one A, and then I again started with the remaining bits. Okay, as simple as that. This particular thing will keep continuing. So coming to my solution, if you see here, and yeah, if you want to see the constants, you can do that. But yeah, there is nothing much here because it's exactly the one we can expect in a middle level question. Okay, repeat limit and SFN both are 10 power 5. Now coming to the solution of this, see here. First of all, I'm creating a frequency array. Okay, and since the number of characters are constant at 26, that for that reason I'm creating it with a constant length. Okay, 26. And if you see here, that is for each character a particular value will be present, and in that value I will be storing the frequency of it. Okay, as simple as that. Initially, all of them will be 0. Then I am storing the ASCII value of A. Okay, so this ASCII value basically means that, see, each character is represented by the ASCII value. Okay, so I am going to store it here because I will need it. Because if you see here, I am only going to store the indexes. That is, if you want to know the frequency of a letter, let us say C, so C will be present in index number 2. Okay, so just by knowing the index, I how to get the number C. So this is how it will be. See, if you take the index in it, so index is going to be 0 to 25. From take the index, add it to this particular value. Okay, that will give you the ASCII of that value. From the ASCII, you can convert that number to the corresponding character. Okay, that is going to be the approach. Now I'm going through all the characters in S. I'm trying to find at which index they will be present. So see what I'm doing. I'm taking the ordinal position of A. That is ordinal position basically means, see, ordinal operator in Python gives you the ASCII value of it. Okay, so I'm taking the ASCII value of the I minus ASCII value of A. This will tell me what will the index in this particular array. Okay, in this particular array, what is the index for this particular character. I will go there and increment its frequency by 1. Okay, simple as that. I'm printing it for your purpose. I'm starting the answer which equal to null initially. Okay, and then this is one of the functions. Okay, what is the use of this? See, the idea here is, for example, you saw here, right? After 2 B's, I have to pause and look for a character which is slightly smaller than B. Okay, which is next to B but smaller than B. Okay, for doing that, I am creating this function. Okay, this function, what it will do is, see, let us say I am at B. Okay, it will start from the index in which V is represented. Okay, in from there it will start. It will go below. That is, for example, if V is, let us say, not B, let us say any other character, let us say a character Y, it will be presented at index 24. Okay, so from there it will start from 24 and it will go towards 0. Okay, that is, it will go towards A. Okay, it will be decrementing by 1. Okay, and it will check which character is present, that is, which character has a non-zero frequency. If we find such a character, yeah, if we find such a character, first of all we will reduce its frequency by 1 and we will return that character. Okay, because that character has to be inserted here now. Okay, in this case A was inserted, right? In a similar way, this character will be returned. Okay, the character which is less, that is the next character for this particular index. That is, if you are at z, it will be returning y. If you are at y, it will be returning the next character which is present. Remember, which is present means which has a non-zero frequency. That also is important. Okay, if it is not able to find any such thing, it will return -1. Okay, so whenever it returns a -1, that means we are stuck. That is, we have, for example, see, if you say like this, see, let us say we have three b's, but we have no other character. Okay, in that case, we are crossing the repeat limit. Okay, so what we'll have to do is we will have to omit this, the last v. Okay, we'll have to omit the last v. We are going to return only these two v's. This is where basically we can use this. Use, okay, do not have all, you do not have to use all the characters. Okay, this is where we'll be using that. Okay, when we do not have anything else to substitute. For example, we had a hey here. Okay, let us say we do not have a and we have only b left, but we cannot have three ways because it is crossing the repeat limit. In that case, we will be, stopping at two b's, and we will not be using the last b left. Okay, so that is going to be the idea here. Okay, fine. Okay, now see here what is happening. So I'm going to start. See, this is going to be a constant loop. That is, it has exactly 25 iterations. Okay, it will start from 25. It will go towards zero. Okay, it will be decrementing. Now, if the character in which I'm currently has zero frequency, I will be, going to go to the next loop. If it has a non-zero frequency, take the character. How to take the character? Index I plus the ASCII value of I, then convert it to a character. See, we'll have to learn two functions here if you're not aware. See, this is going to be ordinality operator. This will tell me the ASCII value of a character, and this is the CHR function. CHR basically will convert the ASCII number to the character. Okay, this is going to be the character that I have to insert now. Okay, now while frequency of I is not equal to 0. What is frequency of I? Frequency of I is the frequency of the current character. Okay, this particular character, what is the frequency? Till it is not 0, we'll have to keep inserting them. Okay, what we'll do, see, this is going to check whether, okay, for example, here after writing two b's, okay, in this case what we did, after writing two b's, we then made a. Okay, for that reason we'll be using this loop. Okay, if the answer is not null 0, its answer is not 0, and the last character of answer is equal to the character here. Okay, that is, I have already inserted a certain number of characters, and I'm again going to insert that character. Okay, so in that case, what I will do is, here I will, this is the where I have to search for the next largest character. Remember that what I'm doing. See, if you like, just ignore this part for now. See the here what I'm doing. I'm going to insert the character for either repeat limit times or any number less than that. Okay, so I'm going to take the minimum of these two. Okay, if the frequency is less than the repeat limit, that is fine. Otherwise, if the frequency is more than the repeat limit, I'm only going to take the repeat limit. That is going to frequency. Okay, I'm going to subtract that frequency from the frequency of I, and then this character is multiplied with the frequency, and it is added to the answer. Okay, answer is string. Remember that. Then when I'm this, because of this while loop, when I'm coming back, that is where this function will be executed. Remember, in the first iteration, this will not be ready. Okay, this will not be used. Only in the second iteration onwards, this will be used. Okay, what it will check, if it will check that already I've inserted certain characters of this. Okay, already I've inserted certain characters of this. Okay, so before inserting the next set of characters, what I have to do, I will have to insert one character, okay, which is, next largest. Remember, currently we are the largest, but we have to go for the next, largest character. Okay, for example, we have a z, we'll have to search for y, x, something like that. Okay, as simple as that. So how to get the next largest character? We will call this function, okay, with the current index. Okay, this function will be called with the current index. This will return me, the next largest character. Okay, if this -1 is returned, that means we cannot proceed further. We have to return the answer as it is. Okay, if -1 is not returned, we will simply add that to our answer. Okay, and then we will come out with if loop, if condition, and then this loop will keep proceeding. So let me quickly run this and show it to you. This is an easy solution. That's why I'm not spending much time, because I'm not sure that. See, just take the solution, go through it once. Okay, then come back and see this video. I'm sure you will be able to understand. Okay, I know I'm, proceeding a bit faster, but I'm damn sure that this is not a hard thing to do. I'm damn sure you will be able to do it. Only thing that you will have to understand is when we'll have to insert the next largest character. Okay, for example, as you saw here, we cannot have three c's, four, that, yeah, more than three c we cannot have. Okay, so after three c we'll have to include another character which is slightly smaller than it. Okay, this is what I'm calling the insert next largest character. Okay, as simple as that. So for the reason only, this all this stuff is happening. And yeah, and coming to space and time complexity, see here, we are having a array which to store 26 values. 26 is a constant number. Every time it will be 26 only. So space complexity is going to be a constant. Okay, as simple as that. Now coming to the time complexity, see this part. This loop is taking yeah, we are going to each character nest, so it is going to take O of n time. Okay, other than that, try to understand this point. See what max can happen. See, only thing we have to understand is how many times this is being called. Okay. See what will happen, max. See, when this is called, it will on the worst case, this will run 26 times. Okay, there will be 26 iterations in this particular for loop. Okay. Now this function can be called in the worst case for each character in n. Okay, that is each character in this particular s. So on the worst case, this will be called 26 into n times. Okay, as similar that for each character, that is for each n, that is each number in n, this thing will run. This loop will run 26 times. Okay, in the worst case, remember, like, see, these are the assumptions. We cannot predict the right thing here because it depends on the limit limit. Okay, I'm taking the worst case limit and the highest value of n. So in that case, it will be around 26 into n times. Okay, other than this loop will run around 26 times for each value of each character, which, so for n characters it will run 26 into n times. Okay, so, but yeah, again, it is overall O of n only. Okay, so this is the basic idea, but we have again a much better efficient solution than this, though the time comes will look still the similar, but yeah, the solution is going to be much efficient. By See, in this case, what we are doing, we are using a loop to find the next largest character. Okay, which is not an efficient thing to do. Okay, for example, if I are in Z and the next character is A, we'll have to use waste 25 iterations, then you have to come to A. Okay, that is not an efficient thing to do. For that reason, the next solution that I'm going to show you, which is even better than the lead code optimal solution, is the heap solution. Okay, in this case, everything remains the same. The frequency array is the same. The SQL again, I'm running the loop and storing the indexes. Everything is same. This is where the difference starts. I'm creating a heap. So basically, I'm again running a loop, and for any character which has a non-zero frequency, I am currently pushing it into the heap. And if you have been following my videos, you'll be knowing that this particular library of heap in Python basically, creates a min heap. Okay, but here we want a max heap. What is a max heap? Basically, max heap means which will return the maximum value in the root. Okay, so for that reason, I'm putting a minus value here. Okay, this is going to be the single element in my heap. Okay, so it has two parts. What is the first part? First part is going to be the index at which it is present with the minus n, and the other part is the frequency of it. Okay, as simple as that. Right. So this I am initially appending them, and at last I'm calling the heapify function. Heapify function will take, okay, coming to time complexity, I will do that later, but just understand the solution first. Everything else remains the same. Okay, this till the max, that is till the heap is not empty, I have to run the solution. So what I'm doing, just pop the heap. Okay, let's see here what is that. Okay, let me quickly show you also how the things are running. See here, for example, in the example number 1, this is how the heap will look. Okay, everything will be with a minus sign. This is the index number that. So what is trying to convey? See, 0 means the character A is present one time. Okay, if you see here, character is present one time. Okay, next, the number in the number 2 basically represents the character C. Okay, the C will be present in the second index. It is present 4 times, so the character C is present 4 times. You can count that out. Okay, and coming to 25 is represented by Z. Okay, so Z is present 2 times. You can count the same. Okay, Z is present 2 times. So this is how it will be represented here. Till the heap is not empty, we'll running this. We'll pop the value. What will pop? The character. Okay, the largest character will be popped. Okay, and with its frequency it will be popped. Okay, fine. I'm first of all, I'm multiplying the index with -1. I'm getting the character by using the chr function. Okay, then I'm just checking whether till the frequency is not equal to 0. This is similar to what we have done previously. Okay, this is exactly similar to what we have done previously, but there is a catch. Okay, till the frequency is not 0, run this loop. This is exactly same as the last solution that I've showed you. Okay, but yeah, the only difference here comes is how to find the next largest character. In this case, what I'm doing is, if you see here, I'm just taking the root value of the heap. Okay, just I'm taking that, and I'm getting the SQL of it. Okay, I'm getting the character of it. Okay, how to get the character? Basically, if you see here, this is how the heap is going to look like. Okay, so this particular value will tell me the next largest character and its frequency. Okay, assume that. So before taking that, you have to multiply with -1. Okay, so that is what I'm doing here. You see here, I'm taking the 0 comma 0. Okay, of the heap, and I'm multiplying it to -1, and then adding the SQL of a to it. Okay, and then I'm using the chr function to get that character. This is going to be the next largest character. Since I've used this character once, I will decrement its frequency by 1. Okay, so this is going to be its frequency. I will decrement its frequency by 1. Okay, after decrementing the frequency, if let us say the frequency becomes 0, then I will have to pop that value out. Remember, this will not happen every time. Okay, only when the value becomes 0, it will be popped. Okay, since I don't want to store anything in a heap which has a 0 frequency, that will be popped. Okay, similar to that, then I will add that to my answer. Okay, so this is how it will be implemented in this case. Okay, this part, previously we are using a whole loop to do it. Okay, this whole function was called and there was a loop running, but in this case we're just using a pop operation to get it. Okay, remember, pop is happening here. Okay, not to get the next largest character. To get the next largest character, if you see, we are not doing any push or pop. Okay, we are doing nothing. This will happen only if the character becomes empty. Okay, as similar like that. And this part is exactly same of what we have seen previous solution. Exactly same part. Okay, we are taking either the frequency is minimum or the repeat limit, whichever one is minimum. Take that many times, multiply the character with that many times. First of all, reduce the frequency and multiply the character with that many times, and write it in answer. Okay, similar that. And if you see the advantage here and why it is better than the LeetCode solution, see here. If you see yeah, let us discuss the complexity, then we'll get to know this. Now coming to space complexity, see here why I'm writing 26 to 26, because first of all there is a frequency array, other than that there is a heap, so it will also have 26 elements on a worst case. Okay, so in total there are 26 to 26 values being stored, which is constant again. Okay, now coming to time complexity, see here is a catch. Try to understand this part. See this loop. Okay, where is that? Yeah, this will be O of n time. Fine. Now coming to the heap, remember in the heap there will be in the worst case 26 values, and remember that each value will be popped only once. Okay, popping takes log n time, and there are 26 characters on the worst case. Each will be popped only once, so the total time the heap is going to take is 26 into log n. Okay, so this is how it will take 26 into log n plus n. Okay, by n here, because of this particular loop, it is going to take O of n time, and 26 was log n for the heap. So on overall it is going to take O of n time plus constant. Okay, this is a constant, remember that. So this will not be part of the time complexity. And anyway, I've considered the worst case for this also. Okay, as simple as that. And now if you see what is better than the LeetCode solution is that, see here, I am popping a single value. See, that 26 values, each value will be popped only once. I'm not pushing anything into the heap after that. Okay, if you see the LeetCode solution, they are even pushing something in the heap, but I am referring, I'm not doing that, because I am able to get the value just with a read. Okay, this is just a read. I'm just reading the zero, that is the root value of the heap. Okay, zeroth index of the heap, I'm just reading it. I don't have to pop the value to read that thing. Okay, similar that. Because of this reason, my solution is even better than the LeetCode solution. You can compare the same, just run the solution and the LeetCode solution. Okay, before running, just comment out the print statements and then run the solution. You will be able to see that it performs better than the LeetCode solution. Okay, so that will be the last thing that I want to show you. Yeah, friends, that was all for this video. I hope you enjoyed this question. This was something really nice. Both the solutions, you see, it has O of n time in both the cases, but yeah, the number of calculations happening is totally different. Okay, remember that part. You can observe the same in terms of time complexity also. So yeah, friend, that was all for this video. I hope you enjoyed it, and I will give the solutions in the comment section. Just go through it, refer them once. I'm sure that you will be able to understand. Okay, because see, like from last multiple days, we are getting questions on heap. So for that reason, in this video, I did not go into the depth of heap, but yeah, I'm expecting that if you have been following my videos, you will be able to understand the solution that I've explained. Okay, because like we have seen in detail, in basic, every aspect of it, especially in yesterday's question, I told you everything about heap. Okay, every possibility about heap that you can get. So I am expecting that you will be in a position to understand this video. So that's why I did not go into very detail of the implementation part here, how the heap is functioning, all that, why we are popping and how the heap is functioning, why heap is needed here. See, the idea is very simple. We want the max value. Okay, we want the character which is the largest character. We want that, and when we are doing that, we may need the next largest character. For that reason, heap is the best approach. Okay, heap approach is the best. Okay, I also mentioned why we are using the negative sign, because we want a max heap implementation and not a min heap implementation. Okay, so yeah, friend, that was all for this video. Please subscribe to the channel. It really gives a lot of motivation to continue further. As you can see, we have completed around 56 days together on a continuous way, and much more is about to come. Please do follow us. This really gives a lot of motivation and hope to continue further. See you tomorrow. Thanks a lot.